All right, so now that you've finished pages 10 and 11 as some practice, let's do a little bit of a review of phase change diagrams, the two different kinds that we've seen so far. So we're going to start up top here with this graph that we refer to as a heating curve. And you guys made these graphs in class, and you viewed samples of these graphs in class. So we're going to compare this graph to our phase diagrams that we just learned about in our previous version of these notes. So let's start with our heating curve, and let's do a little review about what these things can show us. So first of all, it's helpful to label the phases in this graph. And if we're starting down here at the bottom and we have two flat lines, recall that the flat lines represent phase changes. That means we have all three states of matter here represented by these horizontal lines. So down here we would have a solid. Right here in the middle we would have a liquid. And then up here at the top we would have a gas. And you can imagine that down here we have a cold solid, and as the temperature increases, this becomes a hotter and hotter solid until suddenly it's actually no longer a solid, it's becoming a liquid. And then down here we have a cold liquid, and this liquid gets hotter and hotter, and then eventually it boils and it becomes a gas. Then we have a cold gas, and then hotter gas, and then if you get hot enough, crazy things happen. But let's not talk about that yet. We'll come back to that much later. So now let's label what's happening here on these flat pieces. So if we're going across the graph this way, which means we are increasing our energy, that means that here we're actually melting. But if you're going the opposite direction, we would be freezing. And that means you'd be taking energy away from the system. Okay, and same thing up here. As we move this way, this would be boiling. We are adding energy. And if you're going the opposite direction, we were cooling it down, we were taking energy away. This would be condensing. Okay. And let's also add in the definition of these phases. So remember that when we have a solid, we said that they have very strong intermolecular forces, IMFs. Okay, and then these liquids, they hold together, but they're also rearranging. So they have what we're going to call fairly strong intermolecular forces, or IMFs. And then gases, there's lots of space between particles. They're rearranging constantly. They're very good at diffusing. We're going to say that they have very weak intermolecular forces, or IMFs. Now that we have that labeled, let's go over here and answer some of these questions. So why don't you guys go ahead and pause this video right now, try to answer some of these questions, and then when you guys think you're done, we'll resume this video. Okay, so let's go ahead and pause now. Okay, welcome back. You should have just finished your practice. And so what we're going to do here is go through some answers to the questions about our heating curve graph. So here we go. What is happening to the temperature at A? We can see from the graph the temperature is increasing. Next question, what phase is A in? Hopefully you could identify that as a solid. What temperature is B? if we follow this across, right here at 5, so this would be 5 degrees Celsius. What phases are present at B? Remember, we said that this was the equilibrium point, okay, between melting and freezing. So both solid and liquid are present. And then lastly, it says to label the diagram. Well, we already did that. Okay, so now let's scroll down to the very bottom here, and we're going to complete this graph and see if we can make sense of what's going on here. So again, this is a phase change diagram, and it's a little bit different than the one on the previous page, but you can see that pretty much all the same stuff is here. So we still have sublimation and deposition, which means that over here we have our solid state, and that over here we have our gaseous state. We have that triple point that we saw in the little video from the last one. We also have our critical point, which we haven't really talked about yet. We have our melting and freezing phase change line right here. And then we have our vaporization and condensation phase change line right here. And then down here, of course, we have our sublimation and deposition phase change line. Okay. The key thing for you guys in this graph is to make sure you can label the important parts. Label and identify the phases and the phase changes. So basically, should be able to tell us about this. Should be able to tell us about this. Okay, as long as you can do that, I feel like you can read this pretty sufficiently. All right, so now we're ready to do our comparison. And if we go back up a little bit, you'll notice that there's a question here in the middle, and we're going to go ahead and try to answer this question with kind of a Venn diagram, or we're going to call it like a Venn table. So we're going to start by comparing the heating curve. And that would be the one above here. And we're going to try to compare that to our phase diagram. And that would be down below. And just like normal, right here in the middle, we're going to put qualities of both. Okay, so there's your table. I'm going to ask you guys to do these comparisons on your own, and we will check back on Monday to see how you guys did with this. Hopefully that was helpful. If you have any questions, again, either ask your sub or bring them with you to class for Monday. Thanks, guys and girls. Have a great weekend. I'll see you Monday.